Welcome to CivilizationX. The sample is ready, but the next decision is not. Science still runs in serial, because each experiment decides the next one. On a Tuesday at 6:40 a.m., a 43-year-old teacher stops at her kitchen counter, slightly breathless again, waiting for a chain of tests that moves slower than her symptoms. Drug discovery still commonly takes 10 to 15 years. In 2020, DeepMind's AlphaFold 2 entered Cas14, the protein structure benchmark, using neural networks to infer 3D protein geometry from sequence constraints before many wet lab teams had run the next structure experiment. The claim is precise. AI does not remove experiment. It changes which experiment deserves to happen first. Science often looks slow for a physical reason. The loop is serial: anomaly, hypothesis, experiment design, sample preparation, instrument runtime or biological growth, analysis, then an updated hypothesis. A crystallography beamline, a cell assay, a furnace run, a synthesis batch. Each step consumes time, material, calibration, and human attention. One delayed result stalls every decision downstream. Protein shape matters because function depends on geometry, binding pockets, active sites, folding stability, molecular interfaces. For decades, determining those shapes often meant X-ray crystallography, cryo-EM, or NMR. All powerful, all slow. Then AlphaFold 2 landed its result, a median GDT-TS score of 92.4 in SASP14, close to experimental accuracy for many proteins. The shock was methodological. Biology did not first get faster by building more microscopes. By 2022, the AlphaFold database expanded to more than 200 million predicted protein structures, a searchable map of forms at a scale no experimental program had solved directly. The same compression is spreading. In 2023, Genome reported about 2.2 million new crystal structures, with roughly 380,000 predicted stable, ranking materials before synthesis. A mobile robot in an autonomous chemistry study ran 688 experiments in 8 days and selected its own next photocatalyst tests. A lab autonomously synthesized 41 new inorganic materials from 58 targets in 17 days. Large language model systems are now strongest not at replacing validation, but at narrowing search, generating candidates, and summarizing literature, so the next wet lab step starts less blind. So what changed? Not proof, not causality, decision latency. For people like that teacher, AI can help labs ask better questions earlier, instead of wasting weeks on low-value branches. But fast search can still fail. A model can inherit literature bias, miss rare phenomena, or automate irreproducibility through calibration drift, contamination, or a badly specified reward function. The Royal Society's 2023 warning is the real engineering target. Build closed-loop labs that detect when they are wrong. Otherwise, compute-rich institutions accelerate first, while under-resourced labs, neglected diseases, and underrepresented chemistries fall further behind. The next bottleneck may not be ideas at all, but synthesis capacity, validation, regulation, energy, and trust. The process of making and testing materials has been slow and serendipitous for centuries, material scientist Atsuto Seko said. That is exactly what is starting to change. The constraint is real. The data exists. Whether the systems built around it can act on it at scale, that is the next engineering problem. Stay with CivilizationX.